Hi there again, this is Scott from EdgeMath, and I've got a question from a student about when to use a t-test versus a z-test. So when to use the z-distribution versus the normal distribution. So we've got a question here. A county has a mean life expectancy of 73.1 years, and the research team suspects that it's local pollution that's causing this low life expectancy. So they do a test. They give 20 lifeline inhabitants a specially designed filtration system, and they found the mean life expectancy in that group was 74.2 years, and the standard deviation 1.4. So we want to carry out a test to see if there's evidence that the life expectancy was greater than the overall. So we've got the standard deviation of the group, but we've got the standard deviation of the group, but not the overall population standard deviation. So we've got the sample standard deviation is 1.4, but we don't have the overall population SD. So we use a t-test. If we don't have the overall population SD, then we can't use a normal distribution test. We have to scale it so to take that into account. So we are going to calculate the t-value. That's going to be the sample mean minus the overall mean over standard deviation over square root of n. And we should probably be clear at first about the null hypothesis and put this in green. Null hypothesis would be the difference is 0. So the difference between the group's mean and the overall mean is 0. Or another way to put that is the mean is 73.1. And then the alternative hypothesis is greater than 73.1, because we're testing whether the life expectancy was greater than the overall average. So we got mean is greater than 73.1. Or another way to write that is the distance, or the difference is greater than 0. So that's the hypothesis, and then we want to find the t-value. So we plug in we've got the sample mean is 74.2. And the hypothesis mean is 73.1, and then the sample standard deviation 1.4 over the square root of the group size, so square root of 20, and we'll pop that in the calculator. So we pop that in the calculator, I'm getting 3.51. So we should be careful to group these on the top and the bottom. So, and then this is a t-test, so we need the degrees of freedom, and the degrees of freedom, that's n minus 1. So that's the sample size minus 1. So 20 minus 1 is 19. And we can pop into StatTrack. So we can use StatTrack, and you can Google t-distribution calculator at StatTrack. And so we've got degrees of freedom is 19, t-score is 3.51, and it's going to calculate for us. It might take just a second. And it gives 0.9988. So that's 0.9988. And if we look on we can draw out a chart to see what this looks like. So very quick, we've got the t-distribution. It's like a normal distribution. It's got a bell curve, and then 3.51 is out here, and that's telling us this area is 0.9988, and then our p-value, since we're doing a one-way test, that's going to be 1 minus that, so 0.0012, and that's less than the level of significance. So our conclusion is we can reject the null hypothesis. Let's review what that null hypothesis was. We have the mean is 73.1, so we can reject that, include the alternate that we can conclude that the mean of the group of 20 is greater than 73.1. So that's what we can conclude there. So based on this evidence, we can conclude that if the group had a mean expectancy of 74.2 with standard deviation 1.4, we can conclude that it had a greater mean than the overall mean. But we cannot conclude causation, so we can't conclude that the water filtration system actually did that. But there is a correlation though. So great, hope that makes sense, and let me know if you have any questions. Good day.